You
Yeah,
can go ahead.
yeah. Good morning to all. On behalf of PowerSys, I welcome you all for the today's online webinar on Introduction to JMAG version 22.0. Quickly moving on to the agenda of today's webinar. Today we are going to see about the new functions and features that got enhanced in JMAG version 22.0 in terms of speed up of JMAG and what are all the enhancements that has been carried out in circuit and control, and especially in terms of optimization and functionality, what are all the enhancement that is being made. That is what we are going to discuss in today's webinar. The first section we will see about how fast the things are carried out in JMAG, especially in version 22.0. The first thing is regarding the speed improvements. In the screen, you will be seeing that for the models which is having approximately 10,000 mesh elements, JMAG version 22 is 2 times faster than version 22.0. And when we go for a coupled analysis of electromagnetic analysis come thermal, now version 22.0 supports up to 256 degrees of parallelization, and it is almost 100 times faster when compared to a single core, and it is 2 times faster when compared to version 21.0. And in Eigenmode analysis also, it is improved in 22.0 with the 2 times to 10 times faster when compared to the previous version 21.0. And the second thing is that regarding the steady state judgment function, we can able to monitor various result quantities in terms of multiple parameters like average value or instantaneous value or maximum value, by which we can control the steady state judgment function. So how we can do the steady state judgment function is that, hope people who would have started using JMAG version 22 would have seen that in the study properties, in the step control, now we have a provision for stop the analysis when the steady state is actually reached. Here we can select multiple parameters by going through this plus button. So here we can name it, and we can target what are all the output parameters. We can select more than one parameter, and we can target the particular component. And here we can go for whether the maximum value or the instantaneous value, average value, or the frequency component in terms of what we want to stop the simulation once the steady state is being reached. So this is what the enhancement that is being made by selecting multiple parameters at a time to monitor the things and as well as to stop the analysis once the steady state is being reached. And the another enhancement is nothing but, especially for the induction motor, it usually takes more time to reach the steady state. So in version 22.0, when we are converting from speed priority mode to the accuracy priority mode for the induction motor efficiency mapping, automatically a circuit for reaching early steady state gets populated. So by which there is a comparison that is shown at the right hand side, which shows that without using this early steady state circuit component, it hardly took over 1 day for reaching the steady state. By using this enhanced accuracy priority mode efficiency map for induction motor, the steady state is achieved within a short span of time when compared to the previous version. And the interesting feature of version 22.0 is here we have the reduced harder thermal model, which is nothing but with the help of 2D itself, we can compute the thermal analysis and the other electromagnetic analysis. So it is said to be a quick processing of the things. That's why like it is said to be a speed priority mode. It is no way connected with in efficiency mapping. We have a speed priority mode. It is not a kind of that. The naming convention made is due to within a very short span of time, we can undergo the thermal modeling with 2D itself. So that is what like given in this histogram chart. Here we will be seeing that till version 21.2, the processing time for the 3D thermal takes around with 15 seconds or something of it. But whereas in 22.0 with the 2D itself, we can do it with less processing time. And another thing is that like with version 22.0, with the help of inbuilt scenarios and with the custom geometries, we can undergo the magnetic analysis as well as the thermal design evaluation simultaneously with express mode as well as the designer mode. I will quickly show the demo of this feature so that everyone can understand like how exactly electromagnetic analysis as well as thermal analysis is easily carried out with the help of express mode. So I opened a new designer window here in the project. I'm going for select model bar scenario option. So here we have several type of the motor, IPM, SPM. In IPM, we have the outer rotor configuration. In SPM, we have the outer rotor configuration. We have the induction motor model too. I'm selecting the IPM. Here we have the basic rotor and stator models. I'm going for the model combination. Here, till previous version, the existing templates alone, we can use it. But in version 22.0, like we can create our own geometry by using custom template in the geometry editor, by which we can take that template over here. One such example is nothing but like we have created the custom geometry in the geometry editor, which is of rotor full and stator full. So after creating the custom geometry, we are in the position to take such rotor and stator combination. When we click OK, so the model gets uploaded. So here we will be going for which scenario we want to do it, whether we want to carry out only the magnetic analysis with efficiency mapping, or we want to undergo the Cogging torque analysis, or we want to undergo a torque ripple study kind of thing. So this many options we have. Currently, I will showcase you how to do the thermal design with the help of this JMAG quick mode with the help of this model and scenario. I'm just going for this water jacket come spray with the transient state. I'm clicking create. So here you will be seeing the model is getting created. So for our own model also, like we can go for such kind of scenarios. So the analysis parameter view comes into the position, so which is similar to that of express kind of window. So here we will be seeing that all multi-physics environment in a single window. The left-hand side, it is showing the motor model, and in the right-hand side, it is showing the equivalent thermal circuit. So for an example, now what I'm doing is in the analysis parameter view, I'm just taking the water flow velocity and I'm adding the case and I'm decreasing the water flow velocity to something else. And now if I click run, if I click OK, then you can see like how quickly the analysis is being made. Here we can see the results. Here we can see exactly the results for different parts of the machine. For the case 1, if you want to see for the case 2, here we can go for and we can see for case 2 how the temperature is there at each part of the machine. So this is how like a quick processing can be done within this design scenario concept of JMAG-Express Mode and Designer Mode. It's not only for the thermal analysis, we can actually do for all the analysis what I shown here. So by going through the model and scenario, we can go for magnetic characteristic as well as the thermal characteristics. The enhancement is especially for how to carry out the thermal analysis within 2D itself, that in a very short span of time, in order to observe the temperature dissipation at each part of the machine with the help of the graph. And quickly, we will see about what are the enhancement that is being made in circuit and control. The first thing is that here you can see that there are different macro component, inbuilt macro component that is available in version 22. There we have two-phase and three-phase modulation, space vector control macros are available. We can use those modulation space control blocks in order to do the comparative analysis and how far the ion loss is being changed when we use two-phase modulation as well as the three-phase modulation kind of thing. So here in this version, we have the inbuilt macro component. And the another one advantage in version 22 is for the macro component, we can add our own components without redoing the macro component. So the editing is possible in the macro component in this version. Quickly, I will show you so here you can see in the circuit, in the macro component, if you go for the macro, here you can see what are all the things that is added. It's a two-phase modulation with RT, and we have a three-phase modulation macro as well as three-phase modulation macro with RT. We have three-phase modulation space vector control with RT. We also have three-phase modulation third harmonic control with RT. So these are all the macros that got introduced in JMAG version 22. We can just click one and we can drag and drop it. So like that we can do it. So if we go for the two-phase modulation and if we go for three-phase modulation, we will surely observe that once the analysis is getting run, we will see the ion loss that exists in the two-phase modulation control circuit is going to be more. Why? Because the influence of PWM harmonic component is greater when we use two-phase modulation component when compared with the three-phase modulation control circuit. So this is what the difference between using two-phase and three-phase modulation, and we have our inbuilt macro to carry out our simulation. And moreover, I told we can go for editing our own macro component. So we will just see that. Suppose I'm taking one macro component for the next so if I go for show sub-circuit, previously it is not possible to add our own components to the existing macro component. We have to redraw the same macro component, but now it is easy to connect the component that is available in the circuit editor to the macro components. So that is one enhancement that is being made in this version. And the next thing is that regarding the RT block, here we can see that we can actually introduce a reactor between the inverter circuit as well as the motor phase terminals, in which we can realize the harmonic content is drastically reduced when we introduce the reactor in between the control block as well as the motor phase block. So the right-hand side graph clearly depicts that when we use the reactor, the harmonics is greatly suppressed. When we don't use the reactor, the harmonic content is more. And the next thing is that we can actually use some arbitrary kind of component with the existing JMAG RT model itself. In some models, after creating the RT, we may feel that we want to add some extra capacitance or inductance or the resistance. In that case, in version 22.0, it is possible to add either a resistance or a capacitance or an inductance between the terminals of the existing RT block. That is actually possible in version 22.0, for which if we go for a MATLAB, there if we have the RT block, when we double click it, here we have to specify the exact RT file, and here you will be seeing that which circuit to be added, and here we have to call this .cir extension file, which is nothing but I will show you. Like here you will be seeing that I want to add my capacitor between the terminals 5 and 4, and I want to add the second capacitor between the terminals 6 and 4, and I want to add the capacitor C, third capacitor between terminal 7 and 4, each of magnitude 1 e raised to minus 8. So if I load this file, obviously the capacitor will seat in between that terminals. So which is nothing but the RT block will now now the RT blocks has, just I will show you. See, it will be like this. Like the terminal 1, this is terminal number 8, and this is terminal number 5 for the star connection RT block. This is for the delta connection RT block. If you are not at all specifying anything with the help of that .car file extension file, then obviously the software will take that this 1 and 8 are connected in a short circuit fashion, then there is no component that is getting added. But when we specify like this, here you can see that between 5 and 4, a capacitor is going to be added. In this case, if we want to add resistor, then we have to simply replace the C with R. So in that case, the particular component get added between the terminals. So this is what the syntax we have to follow. This is the starting terminal and this is the ending terminal, and this is the magnitude, and which component we have to use, that has to be represented. Then the particular component will add to the particular terminals. So this is what one enhancement that is being made. And regarding with the regarding with the JMAG RT model, now there are more information that is being given to the RT model, because if different users come into the picture, then everyone can see that, especially regarding the slot width and the conductor that exists in the each slot in terms of the conductor height direction as well as in the width direction. So this kind of information is going to be available from version 22.0 when we are creating the RT model. So previously that was not the case. It is especially useful for if some other engineer is going to work with the same RT file, then he will be knowing about like what exactly the width of the conductor and what is the average slot width of the machine and what is the conductor heights in the height direction as well as the width direction. So that is actually possible. And the another enhancement that is being made is nothing but like the harmonic ion loss for the induction motor RT model. Here you can see like we got for different operating points like A, B, C, and D. We compared the ion loss error with the previous version 21.2 with the current version 22.0. The blue color indicates the previous version, and the maroon color indicates the new version. Here we will be observing that the ion loss error percentage is drastically reduced when compared to the previous versions. Any of the ion loss error is somehow increasing at higher load points as well as the higher speed points. Whereas when compared to the previous version, the ion loss error percentage is drastically reduced in the new version. And that's all about the control and circuit part. And previously we have seen that like what are all the speed enhancements that is being made in the new version. And now we will quickly move on to optimization and functionality. So this is one key feature that is introduced in version 22.0. So regarding the optimization and functionality, in terms of structural analysis optimization, the reduction of variance is actually possible in version 22.0, in which what are all the cases with the poor convergence is going to be eradicated by the software itself, so that the simulation time gets reduced to a larger extent when compared with the previous versions. So in the left hand side, you can see that like version 21.2, 21.0 has different cases in which poor convergence cases also coming into the picture, which leads to the simulation time to a greater extent. Whereas in 22.0, this poor convergence cases are drastically eliminated, so that we reduce the simulation time to a greater extent. So that is the case. And the one main thing regarding version 22.0 in terms of optimization is here we have introduced an option called range finder tool. What exactly this range finder tool is and how it is going to be used for our optimization, we will discuss that in detail in the forthcoming slides and with help of the demo also. So regarding the range finder tool, we will be appropriately selecting the range for each and every CAD parameter or other electrical parameters what we are going to be used in the optimization. For an example, like previously, if a model is going to be quite complex, then we have multiple CAD parameters to be optimized to meet out our objective function. So here we will be seeing that the model is somehow complex with the multiple CAD parameters. So in this case, we have selected a minimum and a maximum for each CAD parameter, which is actually shown in green color, which is nothing but the original range that is given by the user. And when we use this range finder tool, what happens? The software itself will adjust this minimum and the maximum values within a bounded region in order to deselect the CAD parameters in which the geometry may break. So such kind of cases will be eliminated by the software with the help of the rangefinder by enhancing the range for a particular CAD parameter, by which whatever the model, for which whatever the cases that is going to be produced, will produce the model without any break in the geometry. So that is what the main advantage of this rangefinder tool. So the right hand side shows the flowchart of it. Initially, the user will be giving the CAD parameter set. When we use this rangefinder module, then it will judge with the machine learning kind of concept with the predictive model, and it also checks with the geometry editor, and it will adjust the range of the particular CAD parameter, and that is actually added to the initial cases in order to avoid the geometry break. So this blue color is nothing but after we are using the rangefinder, here you can see that the parameters like what that are set by the user, which is in green color, is adjusted by the software in order to avoid the geometry break with a complex geometry with more kind of parameters. So the minimum value and the maximum value range is bounded to a particular thing when we use the rangefinder tool, which will enhance the geometry creations without any damage. So the blue color graph indicates that how far the range is getting bounded for the proper creation of the geometries. So it will adjust it accordingly. And this slide shows the impact of why this rangefinder to be used exactly. Here you can see that if the CAD parameters is going to be very less, then in that case, this blue color indicates without using the rangefinder, and the red color indicates with using the rangefinder. Moreover, this rangefinder not only selects the particular bound to carry out the optimization to meet our objective function, without breaking the geometry. It also reduces the number of cases so that the simulation time gets decreased to a greater extent. So that is what's shown over here. For an example of a model with CAD parameters only 15, in that case, the rangefinder cannot be useful, though we can see that the time that is taken for the simulation is reduced when we use the rangefinder. Why? Because with the rangefinder, it will eliminate certain cases for which the geometry may break. Then the second example shows that if we go for a model with the 20 CAD parameters, there, if we go for without using rangefinder kind of thing, then because of such a complex geometry, we won't get a proper optimized rotor itself. So that is what, like, without using the rangefinder for this complex geometry, the cases will break, the geometry will break for different cases, so that it is represented as could not be generated. Whereas when we use the rangefinder option, the range what is given by the user is getting altered by the software with the help of the machine learning concept, by which we will get the multiple geometries which is feasible for practical construction too. So in the similar way, when we increase the number of CAD parameters to 34, 36, and 50 with the help of some complex kind of geometries, without using the rangefinder, it is quite complex for producing the geometries without any damage. That's why, like, it is represented as could not be generated. Whereas when we go for this rangefinder kind of thing, with that tool, the range is getting optimized by the software, so that whatever the geometry that is produced by the software is off without any damage. So this is what the use of rangefinder to carry out the effective optimization without any damage to the geometry, as well as drastic reduction in the simulation time while carrying out the optimization for a particular machine to get our objective function to be met out. So one such example is we have a CAD parameter of 50 CAD parameters, and how rangefinder will also helps us to advance our Pareto curve, so that at the right hand side we will be seeing, like, without using the rangefinder, the improvement may be very short. Our objective is to get the maximum average torque. In that case, like, we are seeing that the maximum torque without using the rangefinder option will be around 21 or something, whereas when we use the rangefinder option, it also advances the Pareto curve, in which we can get the geometry by which a torque level of around 23 Newton meter can also be achieved. So this is also an advantage of using the rangefinder option. So before the rangefinder is going to be explained, we have to know one thing, whether for our model, whether rangefinder is going to be used or not. So that is also given with the help of understanding the difficulty level of our model. With the help of level 0 to level 4, it is clearly shown that after we are running the inbuilt script, whether to use the rangefinder or not, we will judge with the help of the level. If we are getting level 0, level 1, and level 2, we may not use rangefinder also, but for the models with the level 3 and level 4, it is a predefined functionality that by running the script, we may be knowing that without using rangefinder, it is quite complex for getting different geometries to achieve the objective function. So for level 3 and level 4, it is suggested to use this rangefinder option to have a bounded range for creating the proper optimized geometries. I will quickly show you, like, how this rangefinder can be effectively used for the optimization. Suppose this is what the model, like what we have seen. So for this model, you will be seeing that these are all the initial CAD parameters we are actually using it. So this many CAD parameters that is available, and it is one of the complex model too. But where to judge whether this model is complex model or not, whether we have to use rangefinder or not. In order to find the difficulty level, we have to go for the scripts in the toolbox option. We have our inbuilt script, which is nothing but geometry evaluation script. When we run the script, then it will show us the result, what kind of difficulty the geometry has, and whether we have to go for rangefinder or not. So it may take a few minutes of time, whereas I will show you what exactly the output we will get. So this kind of message we will get. So for this geometry, after running my script, it is proven that our model is a level 3, which is of hard category. The success rate of the model may be 0.08% for 22 parameters. So in that case, the software itself is throwing a message to the user stating that it is recommended to use update CAD parameter ranges to avoid the broken geometry and set geometry for the initial generation. So this is what the message we will get for the geometries, what we are going to use with the help of geometry evaluation script function. So this is how it will come. Like we will be giving like based on the SMPs, we will be giving here, and we will be just saving our file. And if we click OK, then it will show that prompt message showing that whether the optimization for this model is easy, moderate, hard, or difficult. With that, we will use the rangefinder option. So once we select the folder location and everything, once we click OK, the message will come. Once the message will come, like what we have to do is we have to just go for the case control. And here we will be going for the optimization. Here we know as per the initial. So as per the initial parameters we set, we are going for the objective function. This is quite similar like what we are carrying out in the previous versions. So after this, we have to go for just a moment. So when we go for the case control with the optimization, so objective function is similar like here in this model also, we are giving the objective function in order to maximize the average torque and in order to minimize the torque ripple in the model. And here the initial case will be 1 before running the optimization study. And here comes the several features of this rangefinder. Previously, in the previous version, we may not be seeing this kind of options. We will just see up to this, do not add unnecessary cases due to geometry or constraint errors. But in the recent version, we have this rangefinder option. Here, since our model is very hard for producing the geometry, here we have to select this update CAD parameter ranges to avoid broken geometry and set geometry for initial generation. Then we have to go for set parameters automatically. And we should also use this extend search range for variables that have reached minimum or maximum in the variable range. And we have to select the variable. So what are all the variables we want to select in order to get the bounded thing with the help of rangefinder option? We have to select it. If we click OK, then the things get done. So this is regarding with the output, and this is regarding with the running things already we know it. And if we go for check and run option, the optimization will be running. Actually, I run the model from my side. It is also not fully run. Here you will be seeing that like multiple cases will be getting generated. And here you will be seeing that almost 2 generations got completed, in which we can see that we are experiencing for this quite complex model, not even a single case with a broken geometry is observed. So this is what the powerful of this range finder model, in which we will get the optimized model without any damage in the parts, and moreover the simulation time is also drastically reduced, and we also get the Pareto curve with a more enhanced objective function. So here we will be seeing that in the initial cases, let me show you. During the initial case, the value what we are going to have is nothing but we fixed our value like this, which is nothing but magnet angle is minimum is 30 and maximum is 90, like that. This is the user parameter in which we gave the minimum and the maximum in the model. So that we will be seeing here in the optimization. When we go for here, we will be seeing the minimum and the maximum value. So the minimum value is previously given as 30 and the maximum value is taken as 90. And this is what the value we gave. And after using the rangefinder function, here we can observe that the minimum and maximum value get changed by the software itself in order to produce the proper geometry without any damage. For this CAD parameter, we have given the minimum value was 6 and the maximum value was 15. Whereas once the rangefinder option is done, then the minimum and the maximum ranges are bounded accordingly in order to produce the optimization in a proper fashion. So it will be quite helpful for the people who are carrying out the optimization without undergoing any damage in the optimized geometry. So this is the main key advancement and enhancement in version 22.0. And apart from that, like there is a direct script interface for a range finder. So this I already shown you people. We can directly go for this inbuilt scripting. So with the help of inbuilt scripting, we can know that how the range is getting, whether we have to go for range finder or not. So that is what the inbuilt script feature. The next thing is that our JMAG is now directly getting controlled by several IDEs of the Python. It's a direct interface between the Python IDE as well as the JMAG. It can be done directly. Maybe we will have a short demo for that. For an example, if I go for this model, here what I'm actually doing is, here I'm going for start recording and I'm going for the conditions. I'm just dragging and dropping my current condition here. And I'm selecting for this component, I'm applying the current direction and I'm clicking OK. And now I am stopping this recording. And with the help of that, I generated the Python code. The same Python code, if I'm going to copy it and I'm going to paste it in any IDE of the Python, preferably we used Spider IDE for the Python, and whatever the code that got generated here, I copy pasted here with the help of the library import option. And now what I'm actually doing is I'm going to delete this condition intentionally, whereas I copy pasted the code here. Once I run the code here, now it will ask for which model this code should be interfaced. So I know that this is the script editor model, what I'm using it. If I click OK, then this IDE will be in direct connect with our JMAG model, and our JMAG is getting directly controlled by the script editor. Though I deleted the conditions here, once I run the Python scripting from the IDE, the JMAG is taking control. So with the codings, what we have recorded and we have copy pasted it and we run in the IDE, the current condition gets automatically populated. So this is how the JMAG is getting controlled with the help of IDE kind of thing. So the next enhancement is nothing but, as we saw in the optimization, here we have a detailed view for the optimization. In a one window, we can see all the things like response graphs as well as whatever the filter we want to apply it. And if we want to run the optimization calculation, correlation matrix, everything we can see in a single window. And the another advancement is nothing but in terms of average iron loss for each part can be computed in version 22.0. So the average iron loss for the stator part as well as average iron loss for the rotor part can be known. With that, it can be used for the thermal analysis, which is coupled to the particular electromagnetic analysis. And the next thing is that, like, especially for some customers, when they go for remagnetization kind of thing, the magnetization is done in phases. In that case, like, there will be an impact of demagnetization that is going to be takes place. So in the diagram, it is very clear that the upper diagram shows if we go for a first level of magnetization, and if we go for the second level of magnetization, like whatever the part that is demagnetized, which is not magnetized fully, which is nothing but the center portion, when we go for the second time, it is getting magnetized. Whereas we are observing at the edges, there is some sort of demagnetization kind of thing. So for this, the hysteresis in magnetization can also accommodated in the new version. So that we can see it here. So there are certain magnet component with the magnetization with, here we can accommodate like treat as a magnetized magnet, or we can also go for the magnet with properties of not full magnetization, which actually accounts for hysteresis during the magnetization kind of thing. So this is also possible in the new version 22.0. So this is one advancement regarding to the hysteresis account of demagnetization process. And apart from that, like, what is the other enhancement we have is nothing but, previously it is not possible to use a CAD link editor, different CAD link editor for the same for a different model that exists in the same designer window. So now it is possible to use multiple CAD link editors for the different model that exists in the same designer window. So that is possible in version 22.0. And apart from that, like, what are the several additional improvement that is made is, like, to our extensive material database, now we added a permanent magnet material from Nishia Corporation. There we have the materials of AL16, L16, A14, RA12TA, A14T. So these are all the material grade for permanent magnet is added to the material database. And there is improved self-learning system. There you can see, like, in the self-learning system, multiple documentations are added. And there is an improved optimization manual for how to set up the optimization using JMAG-2. So these are all the key features that got enhanced in version 22.0. So quickly summarizing the enhancement, there are three parts by which the version 22 got enhanced. One is nothing but the speed up of JMAG. There we have seen that, like, how in a quick express mode we will be solving our thermal as well as different electromagnetic analysis with the help of inbuilt model bar scenario that is available, or the user can create their own geometry with the help of custom geometry in the geometry editor. And we can call our model here, and we can go for different scenarios, like the thermal with water jacket and spray, the thermal with some other features, and cogging torque analysis, efficiency map analysis. Everything can be done in a quick express mode option as well as the designer mode option kind of thing. That is the enhancement being made for speed up of JMAG. And the second thing is that, like, we have seen about the circuit and control. There we have seen we have introduced the different modulation technique macros, and we also seen that how to edit the inbuilt macro components without reproducing the macro components. And we also saw that, like, to the RT block, how different passive components can be added between two terminals that can also be added. And we can also introduce a reactor between the control circuit as well as so we can introduce the reactor circuit between the control circuit as well as the motor phase terminals to eradicate, minimize the harmonic content. And this is what, to the RT model, we can apply the passive component, and detailed documentation to the existing RT model can be done. And accuracy of harmonic ion loss for the induction motor is improved. And regarding with the optimization and functionality, we have seen that like how rangefinder is going to be used to get the geometry without any damage, and how it enhance the speed of the optimization, and also how it advance the Pareto curve in order to meet out our objective function in a better level. And also we have seen that how JMAG is directly getting controlled by several IDEs with the help of Python programming. And we also seen that like average iron loss for each component can be known, by which we can properly couple our electromagnetic analysis with the thermal analysis. And for different levels of magnetization, the hysteresis in magnetization is also accounted in the magnet properties. And multiple geometry editor window can be open for the multiple model that is available in a single designer window. And also we, as I told, we added a permanent magnet material from the manufacturer Nishia Corporation with the grades of AL16, L16, and so on. And there are some improvements in the self-learning system and in the optimization manual, especially for rangefinder kind of thing. So it is not only restricted to the features like what we have discussed so far. There are few other advancements is also being made in the software based on the several features requested by several users, as well as to enhance the software. So people already using version 22 can explore the things, and people who are interested to explore the things can upgrade the software to the new version, by which you can use all the enhanced functionalities in a one go, and that will be highly helpful for everyone. I hope so. So that's all about the key features that got enhanced in version 22.0. I hope the seminar is quite useful, and you got an overview about like what are all the enhancements that is being made in the particular version. So if you have any queries or something of it, you may please ask in the chat. I got the message from Matthias asking that like a spiral control is running via COM interface. So you want to know about like how this function works in Linux. Regarding that, I have to check with our developers. I will surely get back to you through email, how especially for Linux, JMAG is getting controlled with the help of the IDE environment. And also for Dohyun Kang, like I will exactly tell you like how Visual Basic Code can be done. So regarding Fabian, is it possible to output the iron losses in DQ frame so it can be directly be implemented in lookup table? Yeah, it is possible. Maybe we can have a separate session for that also, one-to-one meeting, so that we will discuss in detail like how effectively we can go for a DQ frame iron loss estimation, so that we can directly go for the lookup table kind of thing. Actually, the developers are going for the further development process also, like they are enhancing the software in the upcoming version 22.1 in terms of thermal enhancements and so other things. Mohammed, like you were asking about like a creation of geometry for the axial flux machine. Yeah, you can go for the custom geometry in the geometry editor. There you can create your own geometry and you can call that machine. No, but as of now for axial flux machine, it is not there. Hope you have seen in the design scenario. It's supposed for particular machine only. There you can select the scenarios. You can create your own geometry for the axial flux machine with the help of custom geometry, whereas the scenarios is not possible because the scenarios is restricted to IPM, SPM only as of now. So if we create the axial flux machine also, the particular scenario cannot be applied. So that would be the problem. Abhishek Shukla, like you want to know about the transient thermal analysis of the IPM motor. Yeah, we will have a detailed session on how to carry out the transient thermal analysis of IPM motor. Maybe in terms of 3D, how we can do it, or else as we discussed in the webinar, like how with the help of 2D, we can carry out the transient analysis of the IPM motor with the help of speed priority mode kind of thing, by which the equivalent thermal circuit is getting developed within a quick express mode, by which you can see the different temperatures profile with the different parts of the machine. That is possible. With the help of that pre-knowledge, you can go for the detailed thermal analysis with the help of 3D model too. So hope I have answered to all of your questions. If you have any questions, kindly please put in the Q&A. And for the people, I assured you, like we will come back to you people with the help of the email. And moreover, if you have any queries with the recent version, or if you have any other queries apart from this also, you may please feel free contact with the JMAG support at powersys-solutions.com. Yeah, I think I have answered to all of your questions. Yeah, Abhishek, we will have a special session. Actually, this session covers all the glimpses of version 22. If you want, especially how thermal things to be done, like we will have a separate session for that too. So if that is the case, maybe we will wind up the webinar. I hope so. I think the webinar is informative and it will be helpful. Maybe all of you also use the enhancement that is being made in the software for the projects you are actually doing it. Like CFD features got implemented to some extent, but the detailed CFD cannot be done. Whereas now in the existing version, we come up with the different water jackets kind of thing. And we also come up with how exactly the water flow with the help of flow velocity and everything at the different parts of the machine. So how the coil ends are especially cooled because it is projected outside of the frame kind of thing. So to some extent, we can go for CFD kind of thing, not into a fully CFD, but the enhancements are keep going on. Okay, then thank you all for your active participation. Thank you so much. And once again, I'm insisting that if you have any queries, please feel free to contact us with the JMAG support at powersys-solutions.com. Thank you so much. Thank you all. Frank, can we wind up the session? Hello? Hello?
Oh, hello, Kamal. Yes, I think we can. We can close the session. Maybe in few minutes. We are still trying to type some reply.
Sure. Yeah, sure.
Thank you, Kamal, for the presentation. Nice presentation.
Yeah. Thank you so much.